Hi students, in this video I would like to give a brief introduction about design and analysis of algorithms. So what do you mean by an algorithm? It is a sequence of computational steps to solve a problem. That means to solve a problem we have to perform a sequence of steps. Sequence of steps means one step followed by another. So next is characteristics of a good algorithm. There are 6 characteristics. First one is input. 0 or more input. That means the input to the algorithm is not mandatory. Some algorithm do have the input, some other algorithm didn't have any input. Output. So an algorithm must have at least one output. In case of input, the algorithm may not have any input, but in case of output, the algorithm must have at least one output. Next is definiteness. It must be clear and unambiguous. So the algorithm must be clear and unambiguous. So what do you mean unambiguous? For example, if in the algorithm if there is a condition, if I greater than 0 and I less than 0. So that's the condition, I greater than 0 and I less than 0. That is not possible. I can't be greater than 0 and I can't be less than 0 simultaneously. So if there is some statement like I greater than 0 and I less than 0, it is an ambiguous statement. So the algorithm must be unambiguous. Finiteness. Algorithm must terminate. That means the algorithm must end. We can't write an algorithm which runs indefinitely, or we can't write a program which enter into infinite loop. Next is effectiveness. Effectiveness means the algorithm can be implemented in any language. Language means any programming language. Correctness. For any input, it must hold with correct output. So if you write an algorithm, it must produce the correct output for any input. If it produces correct output for some inputs and incorrect output for some other inputs, we can't say it as a good algorithm. If it is a good algorithm for any input, it must end by producing a correct output. So anyway, our subject is design and analysis of algorithm. So why we analyze algorithms? So we analyze algorithms to find the best algorithm in terms of execution time and storage space. So what do you mean execution time? The time taken to solve a problem. So always we go for less time algorithms. So what do you mean storage space? So how much space needed in the memory to execute that algorithm. There also we will always go for minimum storage space. So why we analyze algorithm? To find the best algorithm in terms of speed and space. We always go for high speed algorithms. That means the algorithms which take less execution time, and also the algorithms which take less storage space. Execution time or running time is machine dependent. So for some algorithm in one computer it may execute in 3 microseconds. The same algorithm in some other computer it may take 6 microseconds. So that is the meaning of execution time is machine dependent. So I have an algorithm which runs in 3 milliseconds in one system, and in another system it runs in 6 milliseconds. So I can't express the running time in seconds, milliseconds or microseconds. Why? The execution time is machine dependent. For different machines it may produce different execution time. So the point is execution time can't be expressed in seconds, milliseconds or microseconds. That is, execution time can't be expressed in unit of time. So running time is expressed as a function of input size. So what's the meaning? So if the size of the input increases, definitely the running time also increases. So for example, if I want to print hello world 10 times, it will take particular time. If I want to print hello world for 100 times, definitely it will take more time than the earlier one. So running time is expressed as a function of input size. In the example of hello world, the size of the input in the first case is 10, in the second case is 100. So definitely the running time to print hello world 100 times is greater than execution time to print hello world 10 times. So running time is expressed as function of input size. So how we write the function, we will discuss it later. Next point is running time is directly proportional to input size. What's the meaning? Running time increases as input size increases. In most cases, storage space is directly proportional to input size. Suppose we want to sort 10 numbers. So we need an array of size 10. Suppose we want to sort an array of 100 elements. There we need an array of 100 elements. So in the first case the input size is 10, the second case the input size is 100. So the storage space is also, in most cases storage space is also directly proportional to input size. So consider this example. I have a procedure called XYZ. So it just print hello world and it print hi n times. This procedure XYZ is executed in two computers, computer A and B. The specialty of computer A is to execute each statement it takes 1 milliseconds, and at the same time the computer B takes 2 milliseconds to execute each statements. So print hello world, it will only be executed once, so it is 1 into 1 millisecond. Similarly I equal 0 is also executed once, so it is 1 into 1 milliseconds. So my question is, how many times this while loop will be executed? This while loop will be true for n times and it will be false for 1 time. So what's the meaning? You just imagine the value of n is 10. The I value will be iterated from 0 to 9. 0 to 9 means for 10 instances this while condition will produce true, and for the last instance it will produce false. That's why it takes n plus 1 into 1 millisecond. Similarly hi will take n into 1 millisecond, I plus plus will take n into 1 millisecond. So the total execution time is 3 n's plus 5. 1 1 1 1 1 5. So it is 3 n plus 5 milliseconds. Similarly computer B will take 6 n plus 10 millisecond. So for the same procedure different computers takes different execution time. So we can't express it in unit of time. So what you only thing we understood from this is execution time of XYZ grows in terms of n. So for when n equal to 10 it will take 35 milliseconds for computer A and for 70 milliseconds for computer B. If the value of n is 100, it will take 305 milliseconds. At the same time this will take 610 milliseconds. So what we understood from this is this algorithm XYZ grows in terms of n. So why we analyze algorithm? To find the best algorithm. In this example I have 3 procedures. All 3 procedures are used to check whether a given number is prime or not. So here I am calculating the maximum execution time. So you all know what's the procedure to find a given number is prime or not. So in the first case I am just dividing the number from 2 to n minus 1. So if the number is 101, I just divided it from 2 to 100. If some point of time it produces a remainder 0, I will just return it as false. Another condition is there, if n equal to 1, it is not a prime, so it will return false. So in the first case I am dividing the number n by 2 to n minus 1. The second instance I am just dividing the number from 2 to n by 2. In the third instance I am just dividing the number by 2 to root 10. I want to calculate the maximum execution time. So it is C plus C. This C denotes first line. It will take C millisecond. This C is for line number 3. This n minus 1 into C is for line number 4. This n minus 2 into C is for line number 5. And this last C is for line number 7. So when this algorithm takes maximum execution time, this line number 6 and line number 2 will not be executed. Why? Because this algorithm takes maximum execution time when n is prime. When n is prime, 2 will not be executed, and also 6 will not be executed. So this is how I find this maximum execution time in terms of n. So let's consider the example 101. So it's a execution time c into 2n. 2n is 202. So c into 202 milliseconds will be taken. Here in this case it will take 2 plus n. 2 plus n is 103. That is c into 103 milliseconds will be taken. Here it is c into 2 plus root n. Root of 101 is almost 10. So it is 2 plus 10. 12 into c milliseconds. So anyway, from these three procedures, the third procedure is the best one. So I hope you understood why we analyze algorithms. So next is types of analysis. There are three types: worst case analysis, best case analysis, and average case analysis. So what is worst case analysis? The maximum running time taken. The maximum running time taken. What is best case? The minimum running time taken. So I will go back to the algorithm. Here what is this is the maximum execution time. You just consider only the first function or first procedure. The maximum execution time is c into 2n. So what's the minimum execution time? Minimum execution time happens when the value of n is 1. If the value of n is 1, what happens? This condition will be checked. It will be true. So to execute this line, it will take c milliseconds. Since it is true, line number 2 also will be executed. It will take another c milliseconds. So it will take only 2c milliseconds. It will take only 2c milliseconds for some computer. Let it be A. So consider if the value of n is prime, what happens? This will be the condition. Suppose the value of n is prime. For example, n is 101. So it will take almost 2 into 101 is 202, 202 into c. If it is 1 millisecond, it will take 202 milliseconds. So that is the worst case, maximum execution time. That's the minimum execution time, 2c. So I hope you understood types of analysis. Average case is nothing but an average running time. So it is something between worst case and best case. So just consider another example. Here I have a procedure called ABC with input n. What is it doing? It just print the value of n, then it will print high, then it just calculate n equal to n plus n, and it is also printing n. So if you notice this algorithm, the execution is independent of input size. There is no loops. So anyway, it is independent of input size. The input is just printed twice, print n and print n. But it is, this execution of this program is completely independent of value n. So you just imagine for computer A, print each line takes 1 millisecond. Totally we have 4 lines, so it will take only 4 milliseconds. And for computer B, it takes 8 milliseconds. So it is actually independent of input size. So running time of ABC is independent of n. This is an example for constant running time algorithm or constant running time procedure. So this is all about the introduction. Advanced topics will be discussed later. Thank you.